Welcome to this video on the Automic Automation Databricks integration solution. In this video, we will explain the Databricks cloud integration and what it brings to the Automic Automation user community. Databricks is a popular data platform used for ETL processing, analytics, and machine learning. Automating execution from within Databricks creates an additional island of automation for IT operations to manage. The Automic Databricks agent allows you to integrate Databricks jobs with your existing enterprise workload automation easily. You are instantly inheriting the advanced capabilities of your enterprise solution to deliver your digital transformation quicker and more successfully. By extending your existing enterprise automation to Databricks, you maintain end-to-end visibility, regain centralized command and control, alerting, SLA management, reporting, and auditing. Integrating Automic Automation with Databricks allows you to run Databricks jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating Databricks, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Databricks processes can then be synchronized with all other environments routinely supported by Automic Automation. Databricks' role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Databricks environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to Databricks jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervised processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Databricks jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the Databricks endpoint and login data, and a job template designed to trigger Databricks jobs. Let's assume we're automating for 4 instances of Databricks. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the Databricks jobs in Automic Automation for each corresponding process in Databricks. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Databricks. We're able to retrieve the successive statuses and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the Databricks integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Databricks is a standard atomic agent. It requires at least 4 values to be updated: agent name, atomic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Databricks instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Databricks endpoint. Finally, we use the Databricks template jobs to create the jobs we need. We match these Automic Automation jobs to the Databricks jobs, reference the connection object, and run them. We're able to supervise the jobs, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Databricks integration. The agent is included in the Databricks package, which we download from Marketplace. We unzip the package, which creates a file system agent /Databricks/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the Databricks job templates. Automic can connect to the Azure Databricks and the AWS Databricks cloud types. In our demo, we will create a connection object for Azure Databricks. Once we have established the connection to the Azure Databricks environment, we'll create a Databricks job. Finally, we'll execute and supervise this job. The Azure Databricks console offers a variety of features accessible through the left navigation pane. From the navigation pane, select Job Runs to view multiple jobs which already been created. When you open one, you can view the details of that specific job. Let's move on to the Automic system. Here, we create a connection object with specific inputs to connect to Databricks. First, we must specify the cloud type. We have 2 options, AWS and Azure. Regardless which cloud type we select, we must also specify the workspace URL, which indicates where the Databricks service resides. With the Azure cloud type, we must then specify an authentication type. We have 3 options: the service principal type, the token from file type where you define the token file path, and the personal access token type where you define your token. You can select the appropriate authentication type from the drop-down list. For this demo, we select the service principal type. Here you must define your Azure AD URL, a tenant ID, a client ID, and a client secret. With the OAuth 2 authentication method, depending on the version of the OAuth 2 authentication method you select, you must either define the scope or the resource. With the AWS cloud type, we must specify the workspace URL and select the appropriate authentication type from the drop-down list. The personal access token authentication type requires us to specify a token. which is a bearer token used to log into the Databricks environment. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Once the connection object is defined, you can create Databricks jobs. There are two types of jobs: run jobs and start or stop cluster jobs. Run jobs in Databricks let you start and monitor jobs. There are two ways to run them: run now and run submit. Run now requires an existing job. You trigger it using the run now payload. Run submit. This execution type allows you to submit a workload directly without creating a job. If you invoke create together with run now, you should use run submit instead. This means run submit is useful when you don't want to predefine a job, while run now is for executing an already existing job. Start or stop cluster jobs allow you to start and stop a cluster in your Databricks environment. For now, we will focus on the run job type with the run now execution type. First, select an appropriate connection object to establish communication with the Databricks environment. Following the connection input, we need to define the execution type. In this case, we have selected the run now execution type. Next, we specify the run now input type. There are two input types available: job ID with parameters and job ID without parameters. For the job ID with parameters, the job ID must be provided in JSON format. For the job ID without parameters, you can either manually type the machine name or select it from the picker dialog. Here, we have selected the job ID with parameters input type. Everything is configured now, so we execute the job. Let's go to the executions view. It shows the list of executions in Automic Automation. As you can see, this is the job we have created and it ended okay. If you go to the details pane shows the remote status field, which tracks the job status in the target environment. The job has been completed successfully. The details panel displays the object variable and Databricks_run ID hash, which provides the intermediate request ID. Let's have a look at the reports. The report captures the final response we received. The agent log lists all the connection details, followed by the job inputs and execution logs. Finally, we see that the job was completed successfully. Let's check the file status in the Databricks environment. This is the job that we triggered and it has completed successfully. That wraps up the demo on how Automic Automation can integrate with Databricks to run, execute, and monitor Databricks jobs. Thank you for watching this video.